Morning students, today we are going to solve the problems given in the miscellaneous exercise on chapter 11. Now the first problem is, show that the line joining the origin to the point 2, 1, 1 is perpendicular to the line. Determine the points 3, 5, minus 1, 4, 3, minus 1. Now consider there is a line and let it be OA. So O is the origin 0, 0, 0 and A be the given point, first point, that is 2, 1, 1. Now it should be perpendicular to the line. Determine the points, another points, that is this is 2, 1, 1 and another line it is perpendicular. So let it be B and C. So the points given is B is 3, 5, minus 1, as well as the point C is 4, 3, minus 1. Now the direction ratios of the question number 1 given, let O is the origin, O be the origin whose coordinates be 0, 0, 0 and A be the given point whose coordinate be 2, 1, 1, as well as they give moreover B also be the given point whose coordinates be 3, 5, minus 1 and C be the given point whose coordinates be 4, 3, minus 1. Now we need to show that the line joining these 2 points and the another line joining these 2 points B and C is perpendicular. Now the direction ratios of OA is equal to x2 minus x1, that is 2, 1, 1, x2 minus x1, y2 minus y1, z2 minus s1. Similarly, the direction ratios of BC equal to 4 minus 3, 1 and 3 minus 5, minus 2 and minus 1 of minus 1, 0. Now, if two lines are perpendicular to each other, then we know that A1, A2 plus B1, B2 plus C1, C2 equal to 0. That is the sum of the product of their direction ratios equal to 0. Accordingly, here 2 into 1 plus 1 into minus 2 plus 0 equal to 2 ones are 2 minus 2 equal to 0. Therefore, the line OA perpendicular to the line BC, hence prove. Now question number 2. If L1, M1, N1 and L2, M2, N2 are the direction cosines of two mutually perpendicular lines, show that the direction cosines of the line perpendicular to both of these are M1, N2 minus M2, N1, N1, L2 minus N2, L1, L1, M2 minus L2, M1. Now let us consider a line R vector equal to A vector plus lambda into P vector. Another line B R vector equal to B vector plus mu into Q vector be the given lines. Therefore, if a line equation of the line is given, when the direction cosines, that is P vector in terms of direction cosines be Li vector, Li cap plus Mj cap plus Nk cap, where the direction, if a vector P vector expressed as a direction ratios means P vector equal to Ai cap plus Bj cap plus Ck cap. But since we are given the direction cosines, we have P vector equal to L1, M1, N1. So, and also Q vector be L2 I cap plus M2 J cap plus N2 K cap. Since the lines are mutually perpendicular, the vectors P vector and Q vector must be perpendicular. Now consider the diagram. This is P vector and another vector B Q vector, both are perpendicular to each other. Let it be angle between them be 90, because given as these two lines are perpendicular, therefore the two vectors P vector and Q vector must be perpendicular. Now we have known about the cross product. Generally A vector cross B vector equal to modulus of A vector into modulus of B vector into sin theta into n cap, where n cap is a unit vector perpendicular to the plane containing both A vector and B vector. Similarly, let R vector be the perpendicular vector, R vector be the perpendicular vector to the plane containing both P vector and Q vector. Now take cross product between P vector and Q vector. Now P vector cross Q vector equal to modulus of P vector into modulus of Q vector into sine of the angle between those two. Since they are mutually perpendicular, it is sin 90 and R vector. Now R vector is a unit vector perpendicular. Therefore R vector equal to P vector cross Q vector divided by modulus of P vector into modulus of Q vector into sin 90. Now modulus of P vector equal to modulus of Q vector equal to 1, because these vectors expressed in terms of direction cosines. Any vector expressed in terms of direction cosines means that vector must be a unit vector. We have studied in vector algebra already. Okay. Accordingly, modulus of P vector equal to modulus of P vector equal to 1. We know that sin theta is sin 90 degree is also 1. Sin 90 degree is also 1. Therefore, the denominator, every value of the denominator is 1 only. Hence, P vector cross Q vector equal to R vector. The required vector R vector equal to P vector cross Q vector. Now, let me rub the diagram. P vector cross Q vector equal to determinant I cap, J cap, K cap, and the direction cosines of, that is components of P vector be L1, M1, N1, and Q vector L2, M2, N2. Now expanding this I into M1, N2, M1, N2 minus M2, N1 minus J cap into L1, N2, L1, N2 minus L2, N1 plus K cap into L1, M2 minus L2, M1. Now rewriting this as I cap, that is M1, N2 minus M2, N1 into I cap plus I am bringing the minus to the inner side, therefore it will become N1 L2 minus N2 L1 into J cap plus L1 M2 minus L2 M1 into K cap. Since P vector cross Q vector equal to R vector, that is the vector perpendicular to P vector and Q vector is in the form of ijk, that is in this game of scalar components. These components must be direction cosines of R vector, since R vector is a unit vector of perpendicular to both P and Q. Therefore, the direction ratios of the direction cosines of r vector, that is perpendicular vector, are m1 n2 minus m2 minus m2 n1, comma n1 l2 minus n2 l1, comma l1 m2 minus l2 m1. Hence proof. Question number 3. Find the angle between the lines whose direction ratios are. Now question number 3. Let P vector equal to A I cap plus B j cap plus C k cap. So consider the vector containing the direction ratios A, B, C, P vector equal to, and Q vector equal to A minus B, B minus C, B minus C into I cap plus C minus A into j cap plus A minus B into k cap. Now we need to find the angle between these two lines. Generally, angle between two lines is given as cos theta equal to modulus of P vector cross Q, P vector dot Q vector divided by modulus of P vector into modulus of Q vector. So this is a formula. Accordingly, the numerator is A into modulus of A into B minus C plus B into C minus A plus C into A minus B whole divided by root of A square plus B square plus C square and into root of B minus C the whole square plus C minus A the whole square plus A minus B the whole square. Now consider the numerator, that is AB minus AC or CA, AB minus CA plus BC minus AB, BC minus AB plus CA minus BC divided by root of A square plus B square plus C square into root of B minus C the whole square plus C minus A the whole square plus A minus B the whole square. Now plus AB minus AB plus BC minus BC minus CA plus CA equal to 0. The numerator is 0, therefore the entire ratio is 0. Now cos theta equal to 0, therefore theta equal to cos inverse of 0, therefore that is the angle is either 90 degree or pi by 2. Question number 4. Question number 4. Find the equation of a line parallel to x-axis and passing through the origin. Consider this three-dimensional O, X, Y, Z. Any line parallel to x-axis and which is passing through the origin means the x-axis itself. The line represents x-axis only, because any line parallel to x-axis means we can draw so many lines parallel to x-axis, but the only one line which passes through the origin means that is x-axis only. Therefore, the line is x-axis. Any line parallel to x-axis and passing through origin is x-axis itself. Now we need to find the equation of this line. There are two types of equations. One is equation of a line in the Cartesian form when the direction ratios are given, that is x minus x1 by a equal to y minus y1 by b equal to Z minus Z1 by C, where A, B, C are the direction ratios of the line. We don't have any direction ratios because only one ratio we can have, that is in the x axis we know we can do, and y axis what are the points are there. But we know angle, what the x axis make angle with the 3 coordinate axes. Therefore, the another line we can use the another format, that is x minus x1 by L equal to y minus y1 by M equal to Z minus Z1 by N. So, this is the equation, Cartesian equation of line when the direction cosines are given. Here L, M, N are the direction cosines. Now, we know that itself, hence the equation of required line is in the form of x minus x1 by L equal to y minus y1 by M equal to Z minus Z1 by N. Here the point, passing through point x1 comma y1 comma Z1 are 0 comma 0 comma 0 because the line passes through the origin they given. Now L equal to cos of the angle made by the line with the x axis. So, x axis makes angle with the x axis is 0, L equal to cos 0 whose value is 1, and M equal to cos 90 because x axis make 90 degree with the y axis, therefore 0, and N equal to the angle made by the x axis with z axis, that is also 90 degree, therefore cos 90 equal to 0. Substituting these values in the given equation, the required equation of line is equation is x minus x1 0 divided by L1, that is y minus y1 is 0 divided by M equal to 0, and Z minus Z1 is 0 and N equal to 0. So, hence the required equation is x by 1, y by 0, Z by 0, that is all. Now, the question number 5. If the coordinates of the points A, B, C, D, B, 4 points given respectively, find the angle between A, B and C, D. Now, let us write given A is of 1, 2, 3, B is 4, 5, 7 and C is minus 4, 3, minus 6 and D is 2, 9, 2 respectively. So, we need to find the angle between AB and CD. First, the direction ratios of AB. The direction ratios of AB equal to OB minus OA, that is B minus A. 4 minus 1, 3, comma 5 minus 2, 3, comma 7 minus 3, 4. Now, the direction ratios of CD equal to 2 minus of minus 4 plus 4, 2 minus plus 4, 6, comma 9 minus 3, 6, comma 6, 2 minus of minus 6 plus 6, that is 2 plus 6, 8. Now, if two lines are parallel, we have to think one concept what we have taught earlier. So, if two lines are perpendicular, we have A1 A2 plus B1 B2 plus C1 C2 equal to 0. If two lines are parallel, we have A1 by A2 equal to B1 by B2 equal to C1 by C2. If two lines are parallel, then the condition is A1 by A2 equal to B1 by B2 equal to C1 by C2. Here A1 by A2 equal to 3 by 6 equal to B1 by B2 is also 3 by 6 equal to C1 by C2 4 by 8 equal to 1 by 2. Therefore, AB, the line AB parallel to line CD. Therefore, the angle between AB and CD is either 0 or 180 degree. So if two lines are parallel means they may not have the same sense of direction or opposite sense of direction. So in both the cases they are parallel. So they must be either, if they have same sense of direction, they acting towards same direction means the angle is 0. If they acting in the opposite direction means the angle is 180 degree. Therefore either the angle is 0 or 180 degree. Now the problem number 6. We are given two lines. If the lines x minus 1 divided by minus 3 equal to y minus 2 divided by 2k equal to z minus 3 by 2 and x minus 1 divided by 3k equal to y minus 1 by 1 equal to z minus 6 by minus 5 are perpendicular. We are given the condition is perpendicular. These lines are perpendicular. Find the value of k. Now for the first line, the direction ratios of first line, that is let it be L1. First line be minus 3 comma 2k comma 2. So consider this as A1, B1, C1 and the direction ratios of line 2 given as 3k 1 comma minus 5. So because we cannot say these are not points, therefore A, B, C. So this is A1, A2, B2, C2. Consider these two. Since the lines are given as perpendicular to each other, we have, since the lines are perpendicular, we have A1, A2 plus B1, B2 plus C1, C2 equal to 0, which gives A1, A2 means minus 9k and B1, B2 2k plus 1 2k and C1, C2 minus 10 equal to 0. Now minus 7k equal to 10, therefore k equal to 10 by minus 7. So this is the required value of k. Now question number 7. Find the vector equation of the line passing through, they are given passing through a point 1 comma 2 comma 3 and perpendicular to the plane r vector dot I cap plus 2j cap minus 5k cap plus 9 equal to 0. Now consider a line and which is perpendicular to a plane. The given line is perpendicular to the plane. Now they are given that it passes through a point. Let A be the point whose DRS is given, that is 1 comma 2 comma 3. Now we know that the normal to the plane is acting perpendicular to the plane, that is n vector is acting perpendicular to the plane. This vector is parallel to A, therefore we can consider as the line passing through one point and parallel to another vector. Here therefore this n vector can be considered as B vector, that is let the equation of required line is r vector equal to A vector plus lambda into B vector. A vector is a position vector of the point through which the line passes. Now B vector is a vector for which the line is parallel to that line, the line is parallel to that vector. Therefore n vector is perpendicular to the plane, our line is also perpendicular to the plane, these two are parallel, therefore the n vector here is the B vector. Now the A vector equal to, from the information given, A vector equal to I cap plus 2j cap plus 3k cap, and n vector is nothing but B vector, the required B vector equal to I cap plus 2j cap minus 5k cap. it is given in the equation of plane. The plane equation is r vector dot n cap equal plus d equal to 0 likewise. So, we can take b vector as this. Hence, the required equation is r vector equal to a vector, that is I cap plus 2j cap plus 3k cap plus some scalar lambda into b vector, that is I cap plus 2j cap minus 5k cap. So, this is the required vector equation. They asked you only the vector equation, therefore, the answer is this is. Question number 9. Find the shortest distance between two lines, line 1 and line 2 given. So, we need to find the shortest distance. On comparing these two, whenever we are asked to find the shortest distance between two lines, we have to compare the vector given with the scalar, that is lambda into something and mu into something. If these two are same, equal or proportional, then two lines must be parallel. Then we can use the formula for finding the distance between two parallel lines, but these two are different. So, they must be skew lines. So, distance for the skew lines, we know that the distance for the skew lines is modulus of b1 vector cross b2 vector dot of a2 vector minus a1 vector divided by modulus of b1 vector cross b2 vector. Straight away you can use this formula. First find b1. I tell you what are a1, a2. Here a1 vector in the form of, generally in the first line we have to take as r vector equal to a1 vector plus lambda into b1 vector. In the second line we have to take as r vector equal to a2 vector plus mu into b2 vector. So, it is a1 vector, b1 vector, a2 vector, b2 vector. Here a1 vector equal to 6i cap plus 2j cap plus 2k cap and b1 vector equal to I minus 2j plus 2k, a2 vector equal to minus 4i plus 0j vector minus k vector, b2 vector equal to 3i minus 2j minus 2k. Now, find first b1 cross b2. First find b1 vector cross b2 vector. We require this. Also find its magnitude, that is b1 modulus of b1 vector cross b2 vector. Find this value and take dot. Also find a2 vector minus a1 vector. Take dot product between these two. It will become the numerator, and the modulus of this value become the denominator. If the value is negative, we need to convert it the positive value, that is we need to take only the absolute value. So, because we have cold modulus, because distance cannot be cannot be negative, therefore we have to take this. So, finding all these values, substitute here, you will get the answer. Now, the question number 10. Find the coordinates of the point where the point passes through 5, 1, 6 and 3, 4, 1 crosses the YZ plane. Let the point given, first point be A, whose coordinates given as 5, 1, 6 and B be the another point whose coordinates be 3, 4, 1. Now, we know that the Cartesian equation of any line passing through 2 points, the Cartesian equation of a line is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. Here x1 y1, first point be x1 y1 z1, and whereas the second point we can take as x2 y2 z2. Therefore, the equation is x minus x1 means 5 divided by x2 minus x1 means minus 2 equal to y minus 1 divided by 3 equal to z minus 6 divided by minus 5. Let it be lambda. We can assume, say, therefore, any point on this line, any point on this line is as x1 comma y1 comma z, x1 comma y1 comma z1 equal to, that is xyz. Here take as xyz, xyz equal to minus 2 lambda plus 5, minus 2 lambda plus 5 comma 3 lambda plus 1, 3 lambda plus 1 comma minus 5 lambda plus 6. Here x minus 5 divided by minus 2 equal to lambda. Therefore, x minus 5 equal to minus 2 lambda, or x equal to minus 2 lambda minus 5 becomes plus 5, and similarly y equal to 3 lambda minus plus 1 plus 1 item. So, minus 5 lambda plus 6. Since on xy, since on yz plane, where they have given yz plane, on yz plane x coordinate is 0, on yz plane x coordinate is 0, that is minus 2 lambda plus 5 equal to 0, or lambda equal to minus 5 by minus 2 equal to 5 by 2, lambda equal to minus 5 by minus 2 equal to 5 by 2, lambda equal to 5 by 2. Now, substitute the points here. Therefore, the required point is minus 2 into 5 by 2 plus 5 comma 3 into 5 by 2 plus 1 comma minus 5 into 5 by 2 plus 6. That is minus 2 cancel, minus 5 plus 5 0. Now 3 5s are 15 by 2 plus 1, 15 by 2 plus 1, that is 17 by 2. Next is minus 25 by 2 plus 6 minus 13 by 2 is the required point. The same way we can solve the problem number 11. Here also you just write the given points and form the equation of line passing through two given points and find the point, the formation of point, what type of point will be there. So, likewise you form this, and in the zx plane the y coordinate is 0. So, make the y coordinate as 0, you can find the value of lambda, and substituting the lambda in the required point we can get the coordinates of the point. So, let me solve the 12th problem now. Eleventh is your homework. Solve the 12th problem. In the 12th problem, they given you 2 points. Similarly, the same way as the given in the 10 and 11. 3 comma minus 4 comma minus 5. The first point is 3 comma minus 4 comma minus 5. The second point is 2 comma minus 3 comma minus 3 comma 1. 2 comma minus 3 comma 1. And they have not any directly xy plane like that. So they have given the equation of one plane. Now it crosses the equation of the plane, that is it crosses a plane whose equation is 2x plus y plus z equal to 7. The same way, the Cartesian equation of a line passes through two given points is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. So we are substituting the points here. Now the equation of the line given the 2 points is x minus x1 means x minus 3 divided by x2 minus x1 means 2 minus 3 minus 1 equal to y plus 4 divided by 1 equal to z plus 5 divided by 6 equal to lambda, say. So any point on this line xyz is in the form of minus lambda plus 3, that is x minus 3 by minus 1 equal to lambda, which gives x minus 3 equal to minus lambda and x equal to minus lambda plus 3. Similarly, y coordinate is lambda plus lambda minus 4 and z is 6 lambda minus 5. Now here the equation of the plane is given as 2x plus y plus z equal to 7. Substituting the values of x, y, z in the equation. Since the point lies on the plane, the required point is lying on the plane, therefore we can substitute these points. We have 2 into minus lambda plus 3 plus lambda minus 4 plus 6 lambda minus 5 equal to 7, that is minus 2 lambda plus 6 plus lambda minus 4 plus 6 lambda minus 5. Okay, minus 2 lambda, lambda 6 lambda. 6 lambda plus lambda 7 lambda, 7 lambda minus 2 lambda means 5 lambda, and here 6 minus 4 2, 2 minus 5 2 minus 5 minus 3 equal to 7, 5 lambda equal to 10. So lambda equal to 2. Substituting the required point is minus 2 plus 3 minus 2 plus 3 comma 2 minus 4 comma 12 minus 5, which is equal to 1 comma minus 2 comma 7, which is the required equation, required point for the problem number 12. Thank you. The remaining problems 13 to 23 solved in the next class. So try to solve the problem given in the 11th sum. Thank you very much.